sklearn, model selection, parameter sampler. Description. Parameter sampler is a utility class in scikit-learn used for generating a sequence of parameter settings for hyperparameter optimization. It draws random parameter settings from a given distribution. Inputs. Param distributions: a dictionary with parameter names as keys and distributions or lists of parameters to sample from. Each value should be a distribution instance, e.g. SCPI, stats distribution, or a list of parameters to sample from. Nitter: the number of parameter settings to sample. Outputs. A generator that yields dictionaries containing the parameter settings. Each dictionary represents one set of hyperparameters for the model. Steps. Define a dictionary of parameter distributions, param distributions, where each key is a parameter name and the corresponding value is a distribution or a list of values. Specify the number of parameter settings to generate nitter. Call the parameter sampler function with the param distributions and nitter as arguments. Use a loop to iterate through the generated parameter settings, which will be in the form of dictionaries. Utilize these dictionaries to configure the model with different parameter combinations. Metrics. Not directly related to parameter sampler itself, as it only generates parameter settings. Metrics are used to evaluate the performance of the model trained with different parameter settings. Visualization plots. Scatter plots or histograms to visualize the distribution of sampled parameter values. Fine-tune parameters. Nitter: the number of parameter settings to sample. This directly influences the search space. Uncertainty methods. Not directly applicable to parameter sampler. Uncertainty methods are used in model evaluation or prediction to estimate the confidence in the predictions. Challenges and fixes. Challenge 1: defining appropriate distributions for parameters. Sample use case that resulted in challenge 1: trying to sample from a uniform distribution for a parameter that has a limited range, potentially leading to unrealistic values. Fixes to challenge 1. Use distributions that better reflect the expected parameter range. Consider using distributions like normal, log normal, or uniform with constraints to ensure realistic values. Challenge 2: generating too many or too few parameter settings. Sample use case that resulted in challenge 2: using a very large nitter, leading to long search times and potentially unnecessary exploration of the parameter space. Fixes to challenge 2. Start with a smaller nitter to explore the space initially. Gradually increase nitter if necessary, based on initial results and available computational resources. Challenge 3: dealing with categorical parameters. Sample use case that resulted in challenge 3: not correctly defining the distribution for categorical parameters. Fixes to challenge 3. Use a list of values directly for categorical parameters. Consider using a distribution like the categorical distribution in scikit-learn's distributions module.